I pressed the wrong button. Don't worry. Alright, alright, alright. Button. Hi guys. Hi Bellum. Hi Team Kitty K. How you guys doing today? Ugh. Glitch to life. Because I had... Yeah. Okay. I had my other camera on. That was why. Awesome. Good to hear it. Okie dokie. Let's see, what am I doing? I'm doing this. Yes, music. Alright. Today will be a pretty short stream because I was in the middle of doing an assignment and I kind of had to finish that, so hopefully we can get this done and then raid Pyromike if he's still streaming. I got the solenoids for the battery vending machine. These will be the ones that these solenoids will be the bread and butter of clipping it to it. These are 10mm solenoids, so they're pretty powerful actually, and clicky too. Hey Darsa, did I get a haircut? Yes, I got a haircut today because I was sick and tired of having hair. I'm going to use these solenoids in order to push a piece of PLA into this battery clip, basically clamping it in place. So that's basically the plan. I'm gonna today my goal is to modify this header piece so I can start printing some of the top components of the battery case here, and then I'm also going to make another like casing for it. I like how I watch enough to notice the haircuts. Yeah, Bellum watches me way too much sometimes. I do agree with that. I host you. What'd that mean? You're gonna raid me? Alright, so the thing about this is like I don't like the way this is designed. I don't like the holes on it, but like this top piece is pretty good. So I have to find a way to replicate that. And also the face crying out for help, that's also pretty good. So I think I'm just going to directly modify this piece by first of all mapping this top piece here. Alright, I'm mapping this top piece here. Okay, and then noticing how these pieces aren't really aligned. Okay. Because reasons. Host you so your stream shows many times the category. Yes. Thank you, TMKDK. That is very helpful. Many times, I see many times. Okay, so I think the first thing I have to do with this one is to basically project all of these sketches. Because I'm literally going to just fix this by editing this sketch right here. And I'm going to cover up all the holes because I'm too lazy to like replicate this exactly, like one for one. So first you get rid of all the holes, okay, and then you get rid of all the sides so that you crop it to place. Like this. Alright, so we're gonna go ahead and just clean this up a little bit. So I only want the I only want this device to extend out to there. So. Okay, and then do it to the other side as well. Basically, oh, that's not too much. I feel like this is like giving me more work to do, rather than not. So I've got the inner shape, I've gotten the outer shape. Now I just have to like make it a solid shape by connecting the dots here. I'm always up for some more speedrun catting. So theoretically, I should be able to just take this and just crop it back. And suddenly, we have ourselves a nice little cap here for our battery case. All viewers can host you just by typing host streamer name in their channel. I see. Very interesting. I did not know that. I am a certified Twitch newbie. I also realized that outer shape isn't gonna hold. Actually, I'm fine with that. I'm fine with that. You know what? I'm fine with that. Oh. It didn't crop this outer shape though. Fine. Crop this line here. Crop this line down here. Why is this longer than that other side? What? Slice. You know what? That's not too bad of a. That's not too bad of a shave. Shave off both the top and bottom. Oh. Alright. Nice and even now. Okay. So I've basically trimmed all the fat down. Just make it look a little bit better. I very much didn't like that. Very much didn't like that. Okay. Let's complain about this corner. I totally agree with. Maybe I should just redesign this entire piece. But like, I kind of don't want to. Because that's like the gripper. Okay. You can't really put a screw through the top now because of that screw over there. I love the face. I like the face as well, though. It's very expressive. Screaming in pain. Oh, I fixed it. Wait, that means the bottom can't be filleted. Yeah, the bottom can't be filleted. .9. Okay. Oh my goodness. Oh, Shivan C, thank you for the raid with party of 68. That's a lot of people. That genuinely jump scared me. Hello, hello. Wait, when did I implement that defend command? I don't remember that. So many, yeah, Team Kitty has so many. I was lucky to have 3 raids. Well, I'm lucky to have you raiding me, so thank you. Thank you, Shivan. It means it's time to words on stream. Oh my goodness. Every single time there's like more than like 5 people on this stream, Team KDK wants to play words on stream. Alright. What am I doing? What was I doing? Right, I was trying to attach this head onto this battery cage here. What is that I am doing? I don't know. I really don't know. Talk about the project. I should probably, yeah. Okay, yeah, you're right. I am making a battery vending machine, basically, in its entirety. So just counting some parts of it. This is the battery capsule. So a battery will go inside here. It's a 4S LiPo battery. And then there's going to be like a battery cage in which secures this in place. And then multiple of these. So it's basically an expanding projects. I mean, I could probably talk about myself too, right? I completely forgot about the etiquette of like what to do when there's a raid. But I usually do electronics projects. I'm a electrical engineering, computer engineering student. But I also do CAD on the side. Mainly do projects here. You know, this is a school project. I haven't had time to do many personal projects, but some personal projects I have done in the past are like this thing, which is a macro board, and also I do like PCB design as well. Can you 3D print this? Yeah. So the plan is to 3D print everything. I have a lot of 3D printers. I think that's one of the hallmarks of my channel for the sellout. Like you can see in the background of my video here, I have a lot of 3D printers. I don't do exercise, Bella. No, I don't do exercise. So the goal is, so here's the thing about this project, right? It's a school project, and I haven't had much time to do it over the summer, which is what I was supposed to do. And so the fact is, this is due in a week, I think. In a week. This is due in a week. And I haven't started on much of it, so yeah, I'm trying to like do this as fast as possible and also print this as fast as possible. Yes, there's an exercise button right there. Oh my goodness. I guess there is. Yeah. So this is like me in the middle of designing this thing. This has been designed before. I'm just like revamping it so that it's more or less more efficient. These little holes here are going to be where the battery locks itself into place inside the machine there. the entirety of this project is this is like a smaller part of a larger project. The larger project being a drone project. I also do drones. So the drone project is one that we want to find out different ways to make the drone flight missions longer. And so I've been working on a small drone of mine, and this is part of that system in which the drone's battery will get swapped out, like without human interaction, so that the drone can go for longer missions without having to stop for batteries. Stream has a blow up a capacitor button. Should I push it? Oh my goodness! I've said before that the capacitor button. I'm gonna do it until like the same stream. I gotta prepare for that. So I remember I blew up a capacitor once and it tore right through like a plastic case, and I was like, that's a lot of energy. I should probably not do this again. And then I put a explode a capacitor button. Canarsa gave me like a big capacitor. Pretty much a drone can recharge itself. Yeah. Is a vending machine like you get snacks from, or is this different? Yeah, it's it's just called the vending machine because I didn't know what else to name this project. But more or less, a robotic arm is going to grab a battery, and this is going to be part of like a rotating battery chamber of sorts. It's just like a way to store and manage the charge of like 4S LiPo batteries, which is like the primary type of battery we use in our drone project. Basically, a drone can recharge itself. Yeah, exactly. So like, there's different ways in my project. There's different ways of recharging batteries from drones, but in this case, we're doing like the physical way. Vending machine is the cool name. Yeah, it's the cool name. Yeah, so like a robotic arm will autonomously get batteries from this machine, and each of the batteries will be stored inside this little capsule. Like the design of it is that the 4S LiPo battery goes inside this little big chamber here, and then there's a smaller chamber right here for like PCBs and like other electronics. This gets connected to this outer shell. If I can blow this up, and this outer shell gets connected to this place. So like the problem with this is that a lot of batteries, if you're doing this in the robotics, connecting the batteries to like your charging station or something like that is like actually really difficult, because batteries usually have like these XT60 connectors at the end with the JSTs to sense the batteries. So I'm basically doing this as kind of like a breakout board in order to connect the batteries with something else, or like another like. If this is like the female version of it, or the female ports, there's gonna be like a male ports, and they just like go together and connect really well. And the holes are wide enough so that it's probably more dangerous for us in that regard. But you're able to easily slot it into something that can charge it. Now that's the point of this little setup here. And if we like mass produce like this sort of setup, I think the goal was to get at least 8 batteries in. Then we can basically have 8 batteries charging at one time. We can retrieve them for our drone or other purposes, and it's much more efficient than like charging it yourself, trying to find out how much voltage there is in each battery, and try to manage all the batteries together. Well, this is just what I'm doing, but like another part of my team is working on sort of like a graphical user interface for this battery system, in which the battery system is able to retrieve like information from it, like what the temperature is, how much voltage there is in each cell, how much voltage there is in full. All this data gets sent into, I was building this thing like off stream. This is kind of like my control panel for the machine here. This is Arduino Mega that's going to feed data into a Raspberry Pi, and then also a control panel with an OLED for like intermittent testing. It's a big project, and this is supposed to be all done during summer. I will say my team is doing really well on the user interface retrieval process, and this project has to be presented in 11 days, and I am like in the middle of my midterms week right now. So, and I have a full-time project. I mean, a full-time job. So, that's also interesting. Hey, TMKDK, I guess your like hosting worked. So, Events batteries, exactly. Events batteries. You should get some VC funding. I don't know what VC is particularly, but I do think we have funding from like some source. I believe we're sponsored by a few companies. What was this? Was the control panel before it fell apart? It was the control panel before like the Raspberry Pi just completely fell out. I hot glued the Arduino Mega to it. These breadboards are press fit, and then all of these are like taped together. So realistically, the only thing that fell apart was the Raspberry Pi. Venture capital. Is it venture capital? Okay, we don't have venture capital funding. We're not that intense. I think it's just like small, these small companies like are sponsoring us. But here's the thing, right? I have this is due in 11 days, and I haven't even like designed a rotating battery chamber. I've only designed this like housing for the battery. It's gonna be a little bit of a rush to the finish. I mean, during today's stream, I had the plan to expand on this and get it to work. Actually, wait, why is this? Okay. Okay, I forgot that top was there. Okay, yeah, so this is the gripper. There's going to be a robotic arm, or there is a robotic arm right now. The drone can charge or change itself or charge batteries. Yeah, that's the main goal that I'm trying to implement within the next year. It's my senior year of university, so it's going to be my final project before I leave. So I hope I can get it to work. That's always the case. We do have, like, I think one drone that broke itself. Well, I broke it. It didn't break itself. I broke it. But we're going to get 2 more drones, and then hopefully those drones will be able to fly, and then it'll land on the ground station, which can repair its batteries. And that's probably the primary goal of this. It wasn't a project that I created. It was something that was, I guess you could say, inherited from, like, previous year. But it's one of like the 3 projects I'm in at school, which I really want to see working, because I think it would have some cool applications in the world, and also I'll be graded on it, which is fun. All right, so this thing, I think I'm just gonna repair it with some fillets right now, because I totally decimated this. This gripper was not my design. It was from one of my friends who has recently graduated from college, and I kind of didn't like it, so I'm trying to like redesign it without actually like having to redesign myself, like redesign the whole thing. So we're just doing some quality of life changes here. Yeah, I think that works out. I'm keeping this face in here because it's funny. But otherwise, I believe. Let's see. I need to put some screws here now. Oh, I already read that message. Never mind. Let me get my notes here. So I think I want to use. M3 screws for the top. Just check my M3 screw dimensions here. Okay, so if I want to go ahead and screw it in from the side, then on the top I'll have to move these holes inward, just so that it doesn't conflict with the screws on the side here. So just make sure things are even. This is 37 millimeters, which means if I want to place a evenly distributed point array inside the middle, then 37 divided by 4 is going to be 9.25. So it's going to be 9.25 from the top, and also from the side. We have this as 5.965, so 5.965 divided by 2 is 2.98. That means every single point must be in the middle of this area here. Draw a dividing line, draw a few points. 2, 3. That one's in the middle, which is verified. So then I can just go ahead and divide this. This would be 9.25. Maybe I'll do like 11. That looks better. Spacing it out mine here. Okay. And then I'm going to hold this with the correct dimensions. So because this is a top, it's going to be a countersunk hole, a simple one, not threaded. And then the dimensions for M3 screw are going to be off the top, 6 millimeters. The depth is going to be 5 millimeters, I believe. And then the top is gonna be 2 millimeters. It's just like Hyperloop, the one I did like last winter, except that this is a lot more of time crunch. 3.5? I think this is 3.5. I think that's 3.5. Let me check. That's 3.5. Yeah, so 3.5 down here. So it kind of cuts into it, but that's okay. And I'm going to have to mirror this, so if I can get my construction plane. That's going to be like a mirror. There we go. I'm going to go ahead and just mirror these holes to the other side. Features. Mirror plane. Cool. Okay, so then I gotta find the sketch that was responsible for these holes on top, and then shift the top holes to the middle, just so that these side holes don't get affected by it. Goes these. Okay, then I need to create a point that's in the center between these two. So if I inspect these 2 points, I see 27.5, so 27.5 divided by 2 is 13.75. 13.75. 13.75. Okay, good. That's that sketch, which means the next one would be the hole. It's recalculating. Okay, and undo these two. It's lagging a fair amount. My computer doesn't like handling big things like this. Okay, so I recalculated the bottom, now I have to do the top. So this one. The distance between top here and this point is 13.75. Oh. I'm going to constrain fix this point. That would be 13.75. 13.75. All right. So that hole's in the center, and then this hole's on the side, and I can just make this invisible. And then I need to go ahead and draw these holes on this point here. So make a sketch, and then go ahead and just project, 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 project. Okay. Finish. Hole. 1, 2, 3. And then 4, 5, 6. And then these are going to be simple holes. They're going to be threaded, flat, and then these are going to be just not countersunk, just regular holes. I'm going to make it an asymmetric M profile. It's going to be 3 millimeters. So I think these are going to be 3 by 8. No, if it goes in 5 through the top, then I'm going to have it 5 through the bottom. And these have to be like a really strong point. So I think I'm going to make it a M3 by 12, which means that the bottom's going to have to be 7 millimeters deep. Actually, no, 5 millimeters deep. It can be an M3 by 10. Oh my goodness. Thank you, Slack, for the 25 bits. All separated as like one party emote thingy. That's a neat little cone-shaped thing. I haven't seen before. What happened to my chat? Hold on. My chat disappeared. I just realized. Alright. Make it larger, model it. Bam. Done. Okay. I'm just gonna check to make sure that nothing is like hitting each other. Okay, seems fine. Alright. Okay. So now I'm just gonna go ahead and constrain or joint these two pieces together. So joint this and also joint this. Oh my goodness. Okay, that's a weird joint. So I'm gonna try again. Why is this sketch showing? Okay, try again. So I'm going to joint this to this. It's a little better. Okay. So I think that's fine. I think the only thing is that I don't like the top fillet over here. I think that's gonna cause problems in the long run. This is fine. I'm just gonna go ahead and fillet this edge, but not the bottom ones. Yeah, I'd find a way to get rid of this top one right here. I want it to be flush. Which fillet was that part of? For fillet. How's the sides? Because the bottom one's flush. I want the top one to be flush too. Where is it? It was safety net. It was that. Three edges. Oh, it was the back there. How do I unfillet something? Fillet. I have to go back and like fix this part. I don't like it being that. Alright, I'm gonna spend some time fixing that. Yeah, because this was out here. See that? So because that wasn't out there, I kind of messed it up when I did it the first time. Conductor Redeem saved my work. Yay, now we're on TV. Wait. TV? What TV? That doesn't sound promising for me. Okay, I can just go ahead and do this. Then I want that one. Then we'll make extrusion to not hit these two pieces. Okay, that'll destroy absolutely everything. Okay, and then these ones are going to be from 9 edges. Okay, and I also gotta fillet this back piece now, so this right here, right here. It's like with 1 millimeters. What was this? Absolutely no idea what that was. Okay, now that's the right shape. The holes also fix themselves, which is just nice. Alright, because they're all parameterized and stuff, which is good. Now I have to just fix the rest of it, so I have to get rid of these fillets over here. Oh, I did find it. Okay, it was the first one. Delete this. Recalculate. Oh, that was for the entire thing. Why? Yeah. Okay. Get rid of that. You know what? Okay, that's fine. It's relatively fine. Don't like that. I don't like this gap being here, but like if I fix it, then everything else will break. So here's what I'm gonna do. I'm gonna make a new sketch here, right? And then I'm gonna go ahead and just project that entire thing up. I'm gonna hide the what is this called? Battery clamp. Okay. And then what I'm gonna do is I'm gonna also hide this sketch, and then project this into that sketch. I know it's not visible. That's the point. Okay, and I'm gonna extrude this outer ring inwards. It's gonna yell at me because it doesn't like that. I'm gonna say no. I want you to like it. Oi. That didn't work out as well as I had hoped. Wait, where did that first one come from? Hold on. Wait, where did everything go? Oh, here it is. Okay. Just hide this. Like I do something and then everything absolutely disappears. Okay. Just go ahead and draw this line down here. Finish sketch. I think this will be a better way of just fixing that fillet. Instead of like doing it the normal way. This is how I'm going to do it. Join. I think I have to do it in like 2 separate sketches. I don't think it liked that. It very much did not like that. I don't know what that did, but sure. Okay, so I'm gonna fix the bottom one first, and then I'll fix the top one. Okay, there we go. How to get rid of fillet 101. Literally the only reason why I'm doing this is to make it look nicer. I think like after today I can finally start printing this thing. You guys can watch me for like the next week suffer because of me trying to finish this project in a week. Wow! Look at that. Boom. Fillet gone. That is so questionable. That is extremely questionable. I can't put a fillet on the bottom because... Okay, where's my joint? This is entirely the joint's fault. Okay, I'm gonna delete that and try again. Yeah, this one's on the bottom here. It's not gonna print well, but I'm fine with that. Come on, come on. Okay. Oh, that's flush. Oh, look at would you look at that? Beautiful. A thing of beauty. So yeah, the bottom one on the battery cage, I'm gonna print the battery cage inside of or through my belty. So because it's a belty print, I'm not gonna have a bottom fillet there. Poor joint, always getting blamed. Yes. All right, guys, you saw it here first. This is the completed battery cage. A bunch of M something screws, the sad face still being there, or the screaming face, whatever you want to call it. These are M3x8s, right? I actually don't know. I put screws in here, and I don't know what they are and what they're gonna be. I probably should measure it. So if I inspect here, I do the bottom up. That's gonna be 12 millimeters. So that's a M3x12. Yes, 3x12, and then 3x8. I should probably write this down. So, battery, chassis, screws. So this one's gonna have six M3x12 screws, and then 6 on the side M3x6 millimeter screws. Okay, And then on the side here, what screws are these? Oh, you can see the other side from there. Oh. My. Oh, I completely forgot about that fact. I'm gonna have to change that too. Uh-oh. Uh-oh. You can see the screws from the other side. 21. Who in their right mind gave me permission to do this? It's an M3 by 20. Is that really an M3 by 20? It's a 6 M3 by 20. It's a really long screw. That makes sense. Okay, I'm gonna have to move this top piece inwards then. Which is the battery beauty. Is that what you want to call it? Oh, and these small ones I think are M2s. So times 4M 2.5 by 6 millimeter. Okay. Alright, now I gotta find that hole. I believe it's this one. Yeah, so I'm gonna fix the middle. And then 13.75. Fix the middle. Is this part of the drone? This is part of the battery, not part of the drone. I mean, it will eventually be part of a drone, but this is part of the battery, which is going on the drone. Does that make sense? Oh my gosh, I got rated. I'm not that famous. Why did it break? Why did everything just break? Okay, hold on. Why did everything just break? What did I do? Save my work. I should probably, yeah, I'll save my work. I'm making this the famed battery cage. It's jointed there. I think that's the issue. It was jointed at this location. Okay, I gotta delete that joint. Ah, it very much did not like that. Okay, you know what? I have to find a solution to this because apparently changing time does not work in this case. I can't just go to my time machine and, you know, like, and decide that I want to do something else because it doesn't like that, apparently. Fusion. Everything broke because you used Fusion. Nah! Everything broke because I went back on my time machine and changed something, and now everything parameterized just got ruined. 13.75 and 13.75. I gotta like redo all my holes now. One day you'll have to be famous enough to have paparazzi outside. Yeah, one day I'll be famous enough to do that, and then like, and people will know where I live because I accidentally dox myself literally in every stream. Hi, Pyro Mike. Michael, have you completed your stream? Bellum was talking about you before you got here. No matter, I'll just have 5 screws. We forget the fitness stream. No. Absolutely not. I hate fitness with a passion. Okay, yeah, hold on. This 5. Oh, look at this. It's the thing of beauty. Yeah, so I need to like find a way to get rid of those back 2 screws without messing up the entire timeline. Cause like, it's jointed there too. Oh no. Okay. It's ruined on the inside. Look at this. How am I gonna physically be able to screw this together? What is going on here? Physically ruined. Like, if I try to, like, undo those two screws, too, they won't be able to joint to each other. Unless I find another way to joint it. How do I fix this? How do I change time? How do I, like, not break this entire thing when I press finish sketch? When you see that oh, it didn't. Did I fix it? I didn't fix it. I very much did not fix it. I saw I create like 18 sketches. What is going on here? Okay. Not everything is broken yet. Not everything is broken yet. Oh, there it goes again. Oh, it doesn't like that. Okay. I think we're fine. I think we were generally fine. Missing reference. I know you're missing a reference. Chill out. No, that's your missing reference. What are you doing? You know what? Out of here. Okay, I deleted that and like everything broke. Snap missing they're both missing a reference now. Okay. Are they bodies? Is that why? That's why. One of them's a top cover. Oh, no. Like, this one joint thing is holding, like, literally everything together. Doesn't like that. Can I just ignore this? Can I just, like, completely ignore this and, like, it'll be fine? I thought I grounded this thing. Main body, ground. Yeah, okay, I'm just gonna ignore that. And it won't break. Okay. You know what? It's not moving, it's yelling at me, but it looks okay, so I'm not going to change it because I don't want to deal with this thing anymore. So 6 M3 by 12 millimeter screws, 6 M3 by 6 millimeter screws, 6 M3 by 20 millimeter screws. I just brought up a ruler in this. What did I do? I just got distracted. 6 M3 by 20 millimeter screws and 4 M2.5 by 6 millimeter screws. I need to like get these screws, by the way. Like I don't know. Well, first I don't know if the school's ever gonna pay me back, but like second I need to get these screws. This bottom piece doesn't have like nice things on it, but that's because it's PCB. All right, this is done. I need to make the secondary part of it now, which is the clamps on the side, which rename it to duct tape. Generally find the transportation engine. Hey, at least this time I'm not making a Hyperloop pod. Right? I can't make the longer one shorter because it's literally like inside of it, and if I make it any shorter, it's gonna have like further implications. Like this is a good solution, I think. Wait, no, hold on. This isn't good. Oh, this top one needs to be shorter. Oh, this top one needs to be shorter. Oh, this top one needs to be shorter. This top one needs to be shorter. You are right. That one needs to be shorter. I did not think about this correctly. Good warning, Kandarsa. Thank you for warning me. This could have gone very terribly otherwise. Okay, you know what? So it's not 6 M3 by 12 millimeter screws. It's 3 M3 by 12 millimeter screws, and then 3 whatever these are. 3 M3 by whatever screw that doesn't like feed directly into this design. Yeah, so this time it doesn't go all the way through. 6 millimeters. M3 by 6 millimeter screws. So 9 of these. And they're going to ask me, why do you have 9 M3 by 6 millimeter screws? I'm just going to say because. Yeah. Vellum did it. Not my idea, but Vellum did it. Yes. Shorter screws. I did need shorter screws. Okay. Okay. All right. This is a good thing. This is a good. Now it's time to put this all into one component. I'm actually like version controlling this relatively okay. New component. Yes. This is gonna be the battery chassis. And then drag all of these components inside of it. Good. 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 Okay. Part 2 is the thing that actually holds this thing together. So it needs the solenoids, which I have to like put in at some point. This thing has a 10 millimeter shaft. Not short, average? No, it is short. Average screw size is like M3 by longer than that. So this thing is going to be attached to... So you have to think of the solenoid. Okay, so what state it is in. So when it is in the off position, because we don't want to like power this thing on like repetitively, when it's in the off position, it'll be extended, right? It'll be clamped down onto the battery. Because if the drone is in the air and you have this thing holding this battery together, by the way, these two solenoids, I have another one over there, but these two solenoids are the only thing that's holding the battery together while it's in the air. So, it has to go 5 millimeters deep to clamp these 4 points on the battery together, because this is 5 millimeters. And then also extend outwards by a certain amount. So there's a little screw thingy in the middle of the solenoid, which I think I'm going to put a screw through. I'm not sure which screw this is. I'm going to have to look at the data sheet for it. But it's going to be extended outwards, so into the battery. And then when I power this on, it's going to clamp this inwards and pull it back. So I clamp this inwards and pull it back, right? And the distance is going to be 1 centimeter, I think. The throw on this is usually like ridiculously small for some reason. Actually, this doesn't even look like it's 1 millimeter. It lied. It's not 10 millimeters. It's like 5 millimeters. Huh. Hold on here. Going back to the Amazon. That doesn't look right. That doesn't look right. What did I buy? I bought the solenoid. Right. It says 10 millimeters push-pull solenoid. It's not 10 millimeters. It's a lie. Stroke is 8 millimeters. I brought the wrong solenoid. Bought the wrong solenoid. But it's only a 5 millimeter. You know what? Okay. It says 8 millimeter stroke on this one, which is okay, I guess. I think you can still use this. It just has to pull it out of the... It just has to be more than 5 millimeters. But like the problem is, I don't even think this is 5 millimeters long. It's like just barely 5 millimeters. This solenoid is like the only thing holding this battery together. So I gotta make sure it's okay for her doing that. All right. So here's the idea, right? Here's the big idea behind this. The case is going to be composed of basically 3 walls. One wall on the bottom, which holds the male counterparts to this female piece, so they can slot inwards together, right? And then it's also going to have 2 side walls. One side wall being the one on the right and the one on the left. And these two are going to have like push walls, basically. They're going to hold a solenoid, and the solenoid is going to hold a wall that moves back and forth between itself and inside this battery cage. So when the walls are inside the battery cage, it holds it in place, basically. With these four points right here, absorbing all the force that comes from like the variations in the solenoid pushing and pulling, right? So it's not that too difficult. Also, the bottom wall. It's also going to have a bottom wall, but, you know, I digress for now. So for that application, I think first thing I'm going to do is I'm going to construct the right and left wall with the... I'm going to construct the right and left wall with the solenoid in place, which holds for the solenoid and stuff. And then I'm going to go ahead and make the left wall. What are the distance for these holes? Did they ever specify this? Let's look at it. This is something that I'm going to have to test. This is 15 millimeters. .5 millimeters. Why did they not give like a data sheet for this? Come on. Okay then. Alright, so if I'm gonna mount this solenoid onto the 3D component and then slot the wall inside, if it's extended, it's gonna have 5 millimeters. So like I'm gonna like assume that it's all the way inside of the battery cage right now. Then the solenoid will be approximately 45 millimeters. It's gonna be like 44 millimeters away, and then all the way in 38. So 44 minus 39. 44 minus 39. This is exactly 5 millimeters. This is a lie. This 8 millimeter stroke is a complete lie. I'll measure it one more time from the back. So from the back it's 12.5. $17.8. It's 5 millimeters. It's not 8 millimeters. Oh my goodness. I'm gonna have to get the bigger one just to make sure it has a longer stroke. So that means that use the step over depth if you can. What is the step over depth? It says the stroke is 8 millimeters on the side, but it's literally not. It's literally 5 millimeters. That means this has to be so exact, like it's unbelievable. Okay. Measuring tools. What am I looking at? I just did that. It's 5 millimeters. Using the back of the calculator. I just did that. Yeah. It's that false advertising. Okay, it's okay. So at the very when it's all the way compressed, I need to give it at least a few millimeters of tolerance from the back. So when it's all the way compressed, it's going to be 39 millimeters away. So maybe like 40 millimeters from the back I'll give it. Okay. 40 millimeters from the back. I'm going to make another offset plane here. And this time it's going to be 5 millimeters from the back. I'll save this one for later. On this plane, I'm going to be just basically stealing this entire thing. And then I'm going to crop off the bottom just so it's even. dimension it so that it's 5 millimeters away. Okay. And then I'm going to put a fat offset right here. Right. Oh. 0 points. You think 0.75 millimeters is good enough tolerance? Or maybe you have to do 1? A full millimeter of tolerance, okay. For here. For here. For here. Good job so far. Thanks, Kandarsa. -1. Okay. Sure, I'm pretty sure I'm doing this really backwards. Extremely backwards, but, okay. So I'm going to assume that I'm going to give it 2.5 millimeters in depth. This thing is literally going to fit together like a puzzle piece. And then I'm going to create another plane on the back here. And then again, project that. Okay, make a 5 millimeters. And then extrude. Oh. 5 more millimeters. And voila! Boom, done. Little press fit piece that attaches to the solenoid. Okay, I'm gonna give this a really fat fillet on each side, just so it's like a rounded piece and it's not like very blocky and stuff. I wonder if the solenoid can even like push this. Oh, that's gonna be like a fun little challenge. Does this fit inside of the battery? Okay, because this is the center of mass for the... actually, no, I'm gonna find the center of this piece. So create a sketch and find the center. And then I'm going to create a piece that basically slots into the solenoid, so that it can attach really well to this top little piece right here. So this is going to be a circle with about... And I'm going to have to like print this to test it out, if it works in real life or not. Say 7.5 millimeters. Oh wow, that was tiny. I don't know if this is where the solenoid is. I'm not sure if it can actually hold this entire big piece, but we'll see. The solenoid is pretty strong. It is pretty strong, and I'm using PLA. I can always print this out with carbon fiber if I really wanted to, but 12.5. Okay, I'm gonna give it like that much range. Okay, and I gotta deal with like the inner piece as well. So the inner piece is 2.75. That's 2.5. I just make it 2 millimeters. I'm like very close to like the tolerance point. I'm gonna make it 2.25 millimeters in the middle. So in the center of the in the center of whatchamacallit, the solenoid, there's a little rectangular piece. The center rectangular piece that is 2.25 millimeters, I think. And also the height doesn't matter. Let's see, 15. So when I extrude this, I basically have to extrude these 4 parts, or these 6 parts, and then also extrude the middle piece. And then leave this outwards. So like a little bit of a symbol here, if you know what I mean. And then also extrude this to the depth of the solenoid, which the depth will be about 8.5 millimeters. Look, Kandarsa, I'm using the back of the calipers to measure this. 8 millimeters. Yeah, okay. Is that not how you're supposed to? No, I used topic for earlier. I'm just showing you. I'm using the bottom now. All right. The end of proud. Alright, I'm gonna put 8. Well, every time I measure it changes. Why does this change? I'm just gonna put 8 millimeters, it's fine. So theoretically, the things slot into here, and I have to put another tangent plane right here. Make a sketch. Make a circle. Alright, now this circle, I think it's an M2. What screw type does it fit? No, just kidding, it fits an M3. Okay, so an M3 hole all the way through here. And the depth of this is going to be approximately... $3 millimeters from the top. I hate it when companies don't give me a data sheet for their Chinese-made products. Makes it so much more difficult to like reverse engineer how this works. All right, screw hole all the way through. Okay, simple hole. Oh, no, this is a threaded hole actually. Or no, I'm gonna put a simple hole in that. I'm gonna put a nut on the back of it. Makes my life easier. Alright, and then for an M3 screw, the bottom is 3.5 millimeters. Alright, our solenoid junction attachment thing is complete. Looks good enough. So then, because that was like a 12 millimeter throw, I'm going to need an M3 by 14 millimeter, I think? Or like a 15 millimeter, and then I'm just going to put a nut on the back of it. Yeah. Okay. Solenoid attachment piece complete. This was not part of the original body. Just components for bodies. Solenoid. Solenoid clamp. New components. New components being I don't want this to be inside of it anymore. Get me out. Get me out. I know why. I don't know why. I know why now. I'm gonna name this as battery chamber. Battery chamber. Okay. Now that we're dealing with the battery chamber instead of the battery other thing, I'm going to have a solenoid clamp on this side. This looks like a fun piece to print, doesn't it? How do you print this thing? You resin print it. Oh, this will be a fun thing to resin print. Okay, I'll figure out how to print this thing later. But I need 2 of these. Let me mirror this. Instruction, plane. Mirror, objects, bodies, mirror, plane, new body. Great. I bet this body is still part of the other one, huh? Nah, it's part of solenoid clamp. Whatever, I'll fix that later. Okay. Well, we have 2 solenoid clamps on each side now, and with a fun little geometry dash looking symbol on each side. Cool. So I'm gonna actually joint this first because they're both components, just to make sure that they're inside of it, and I'm gonna make the actual solenoid holder after it. So, joint. Center of this piece to ooh, look at that. Look at that. Okay, so I think that's 2.5 millimeters the way, like, that's half of the way there. Which I think is fine. Because I think that's literally all it's gonna... It's not gonna go all the way back out, I don't think. Unless I get, like, a solenoid with a larger stroke. So, that's gonna be fine. Very much likely not gonna happen, but... one can hope. This is just a guaranteed way of making sure it makes it all the way out, even though it might break in the process. Like, it's literally going to be hanging on by a thread. Okay, what the heck did I do to... I did this, right? Okay. But it's going to be hanging on by 2 threads. One on the front and one on the back, so... take that. Okay. So this is the compressed version of the solenoid. I'm going to need a way to fit the solenoid now. So I'm going to go ahead and create a offset plane on the bottom of this figure. And I'm going to make it with like 0 millimeters of offset because, yes. Okay, so I'm going to go ahead and hide the battery chassis just so I can like make this thing. This is the compressed position, which means that when it's extended, it's going to be, it's going to push itself outwards, right? So let's say I have, what's this plane here, and if I have the battery chassis, I can actually make it based on the plane. I'm going to put this, I'm going to go ahead and parameterize or project this thing outwards. And so this bottom face is going to have to encompass, you know, the female parts, or sorry, the male parts of whatever this is going inside. So basically, I'm going to need to draw, or just to get this part too. Okay. And then I'm also going to need to extend this out maybe like 15 millimeters. I think that's enough. Yeah, just to like to make sure that the back is connected to other electronics and other stuff like that too. Maybe just like a processing chamber on the back for like, yeah, okay, hold on. I'm gonna extend it a little bit further than that. Maybe like 25 millimeters. Yeah. So that way there's like a wall on this side and then some circuitry just to turn it back into a XT60 and 5 JSTs or whatever else is going on at the output. I'll make it 30, why not? That should be enough room. I'll make it 40. Okay. Alright, get rid of this. And then I'm going to go ahead and extrude this from the bottom. I'm going to keep the holes, because why not? Gonna make it 2.5 millimeters in the bottom. Actually 5, because this needs to be pretty strong. And then I'm going to go ahead and make another sketch on here. And then go ahead and map this face on it. Okay. And then I'm going to go ahead and just extrude these two pieces outwards. Okay. Basically, it's going to have the same figure on the top and bottom. Like when it's in the battery chamber, you can see the battery all the way through. But this piece is just to hold it together. Okay, and then the next part I didn't really think out that through. All right, do some quick math here. We'll have a fun fan. What is a fun fan, Bella? What is a fun fan? A cooling fan. I don't think so, unfortunately. Oh, you know what? I can probably skimp out on the circuitry on the sides and just like make it wider. Make it like a wide circuitry block. Okay. Dealing with the solenoid. To deal with the solenoid, we need to find some way to attach it first. So, because this is the extended portion of it, I'm gonna measure it like extend. Why are like these Chinese solenoids always so oily? Okay, so measuring it extended, it's about 44 millimeters. I'm gonna go ahead and make a sketch on this plane, I believe. Yep. And then I'm gonna project this figure on here. And then I'm gonna go ahead and just measure it from the center. So it's gonna have to be 44 millimeters from the from this point, right, where it's all the way inside. So 44 millimeters from here. I'll make it 45 just to be safe. Seems like a fun number. Also, is the shaft supposed to pop out of the solenoid? Because my 24 volt one did. I printed a little enclosure to hold it on. The shafts. Wait. I don't think so. I don't think this is supposed to pop out unless like yank it hard enough. It's like all the way in. solenoid ASMR. All the way until it isn't. True. Truer words have never been said. Some yes, some no. You never know. Okay, like 10 millimeters at the top. You think it needs really that much of a attachment? I'm gonna do this side and then flip it over to the other side. All right, so theoretically, this is what we're working with. How high is it? So from the top, it looks like it's about 8 millimeters, which isn't an issue. This is going to require some print testing that I don't have time for. Okay, so the current distance between this tangent point here, the bottom, please give it to me right, 13.75, which is way too much. I think it is literally 8 millimeters. 8 seems to be a common theme for like these objects. This 10 here. 10 actually. So 3.75 millimeters, something along the lines of that, and then make a little block on the end here. For the bottom piece. The bottom piece is 25 millimeters. Oh, I sure hope I get this right the first time. This is going to be such a pain to test out. And then extrude this 3.75 millimeters up. This is basically the solenoid holder. Oh, this is such a sketchy design. This is such a sketchy design. Oh, man. Oh, man. Alright, so theoretically, if I get everything right, there's going to be a point to the top right and to the bottom right corner of this, somewhere here and here. That is incorrect. It should be on the bottom right corner and the top left corner. So here and here. I sent a pic on Discord. The little rubber thing popped off, so the whole thing came apart. Let me see this. Hold on, let me see if that's true. Let me just take off the rubber part on my solenoid. I see you also have a cheap Chinese solenoid. Wait, no, because there's like a little like nut keeping it in place, Bellum. There's supposed to be a little nut keeping it in place. You see that? I don't know. So if that nut popped off, then everything is gonna fall apart. Mine must have been missing that. Maybe so. All right, so I'm gonna go ahead and just do this relative to the screws that are on this thing. So approximately, now the vertical approximate difference between these 2 points is around 15 millimeters from this point to this point. Or it can just give it to me like that. Okay, you know what? Okay, fine. So around 15 millimeters from the front to the back, and around I'm gonna say 12.5. I think like that's a nice even number. So Pythagorean theorem: 15 squared plus 12.5 squared, and the square root of all that. 12.5 squared is 19.526. Okay, I was gonna say watch it crash. It did not crash, so that's good. Okay, now I gotta center this entire thing on there. I have no clue how far these are from the edge. So I think they're equal amount from like the top and bottom edge. I would say about 4.5 maybe? 4.5 from the bottom and from the top. So maybe that. 4.5. Close enough. 4.55. Watch this be so wrong in the end. I'm gonna print this out and I'm gonna be extremely disappointed. 4.6. 4.575. Take that. Okay. And then from the edges, the smaller one is definitely closer to the edge than the larger one. The way I measured it. The smaller one is about 2.5 millimeters from the edge. You know what? Good enough. I know these are 2.5 millimeter screws, I believe. Are they? These solenoids usually really like putting two M2 screws on the edges. I think it's an M2. When your Hyperloop engineer says close enough. I'm gonna see if it's an M2 screw. It was not an M2 screw, it was an M2.5. M2.5, which I just dropped and it's going to roll into the floor and into the abyss. It's different. It's a 2.5 millimeters screw for once. No, it's not an M2.5 millimeter screw. It's an M3. I think it's M3. I don't know if it's an M3 anymore, guys. Let me test this. Oh yeah, it definitely is. Okay, just kidding. It's an M3 screw. It's an M3 screw. I heard when a Boeing plane goes on its first flight, they loaded it with the people they built it. Will Lachlan go on the first ride of his Hyperloop? Oh, I absolutely will. And that's really that's a really funny fact. 4.11 millimeters deep. I think they use a test tools. 2.5 millimeters deep. Okay. So in that case, I think we need to put them to the bottom, just so that they're flush. If it's an M3, then I have more M3 screws to put in my to use as my advantage. Okay. This will be simple counter bore, and then 9, 8, 8.5. Good. Okay, so 6 millimeter, 2 millimeter, 3.5 millimeters. You know, the usual M3 dimensions. You know what? That doesn't look half bad. I will be the judge of that later on. That definitely looks half bad. You know what? Before I make these holes, before I do anything else, before I hold my extrusion. Let me just like shift time here. Good, good. Let me just make sure that doesn't happen. Okay, what is this? Body 12. That is part of my. As I'm gonna deal with that later. Okay. Solenoid. I don't know if this will work. I hope this works. I sure do hope it works. Let me just put some fruitful fillets here. Oh, the bottom can't be filleted. And the sides. Yeah, so that's gonna be the solenoid holder. Do I know if this is gonna work or not? Absolutely not. Sure, try to print it, that's for sure. Will it even print? I don't know. Okay. I don't know if this will work. I don't know if it has enough structural stability to function correctly. If I make something like along the sides here, it might. Because it's only hanging on by literally that like one piece of filament down there. Like otherwise it's gonna crack. I might have to just make something there to prevent it from cracking. Also, that's not good. One, two, no, 3, 4, 5, 6, 7, 8, 9, 10. In. Okay. That way the bottom isn't filleted, so my belty doesn't like absolutely hate me by the time I finish this project. I think I need to add like a frame to it, at least diagonal frame, so that it doesn't like blow up on my face. Not before I mirror this to the other side and pretend I did more work than I actually did, though. Mirror. Why? Compute failed. Okay. Alright. it didn't like that. Okay, good enough. Yeah. Oh, this looks so questionable. Will this even work? If I these holes aren't mirrorable. This side they are correct. I turn it around. These holes need to go on the other end. Okay. These holes are not right. So I need to correct for it. And this looks fine, but like those holes are not right. I'll have to like mentally remind myself not to do that. Yeah, I'm not sure. Right, so if you touch the solenoid on the right side, then these holes are in the right location. And then on the left side, it's just a rotation of 90 degrees, which means, yeah, these have to be on the other side of this. Okay. I'm just gonna go ahead and project that. Create a point right here and right here. Okay, and then I create a sketch down here. Project these 2 points, and then hole. You know what? That actually doesn't look half bad. I might just like end up mirroring this to both sides just in case I mess up even further, which I think I know I will. You know what? I'm gonna mirror that to both sides. They're gonna be like, why did you mirror like 2 more holes onto the other side? I'm gonna be like, because. Construction plane. Why won't it let me mirror my feature? It does not think it's a feature. Mirror. Okay, never mind, it reverted it. Are you kidding me? Okay, you know what? You know what? I tried. It didn't work. I'm not trying again. I'm just filling these holes and leaving it to be. Okay, so which one is it? If I do it here, look at it from the back, it's gonna be that hole. So I need to fill in this hole and this hole. So extrude from there and there. Distance to objects. No. Distance. Like 8.8. Negative 8.8. 0.7. Okay. So that one on that side. This on the other side. Okay, you know what? That is okay. I don't know if it'll work, but good enough for now. Let's see what it looks like with the battery chassis. Looks pretty good. I just have to make the piece on the end that you know goes right into where these holes are, and then I think we'll be fine. Okay, let's do that right now. I'm gonna construct a plane and offset it by like nothing, because why not? Create a sketch here, and you project this entire thing. Okay, and also need to project the innards as well. So I'm gonna do this based on the offset, so this is gonna take a while, because I didn't think about the consequences of my actions before I started doing this project. Save my work. Thank you, Narsa. Wait, did it not save my projection? Hold on. Okay. No, it didn't. Okay, good, it did. I was about to say, did I save my work and did it get rid of my work during that save? That would have been insane. Alright. Oh, it's 11. Oh, time flies by when you're having so much painful fun. I should probably go soon. All right. Let me just finish this. Let me just finish this real quick, and then I'll go. I don't get into your hair any longer. I know it's not visible. Stop yelling at me. That's not visible. All right. All right. So this is gonna be. Have a further offset like 0.5 of a millimeter. I'm sure that will that'll work fine. Okay, and I'm gonna offset the rest. Offset. So that's 0.5 millimeters. Okay. All right, I think that's a good point to leave it for today. I might work on this tomorrow. Actually, I have to work on this tomorrow. I'll print out some of these parts so that we can see what it looks like, just to make sure it works correctly, especially like this bottom part. I can get started on printing on the battery chassis though, so I'll go ahead and do that. I think that's it for me today, though. I probably have to get back to doing my my exam that I started before the stream. Not my exam, my assignments. I have too many exams to count at this point, so. I'll get going for today, but let's see. Do any of you guys have someone you want to raid? No one's online on my friend list. What about a pull request? I'm gonna deal with the pull request later, Pudars. I'm a little overloaded right now. Oh, I didn't see Cass's message because Cass was the same color as Bellum, but I saw it on Twitch. But Cass said you need to fill this hole in that hole. That's what she said. It was everybody, how you doing, brother? Hey Cass, sorry to get to your message so late, but I'm doing pretty well. I'm just ending the stream for today. You guys have anyone you want to raid? AntCam1337. Okay, we're going to AntCam1337 then. Okie dokie. We're gonna go look at some ants now. All right. Maybe it's gonna be my outro here, but I hope you guys enjoyed the stream today. It was so fun doing this with you guys. Thank you so much again for Shivan for rating me with so many viewers. All the extra viewers, so many viewers. But I hope everyone was able to enjoy their time here. And I hope you got a good time. I'm gonna get out now. Arc Phantom Redeem save my. Thank you. I should probably save my work. And that was actually a really good idea. Because I was gonna end stream, my fusion was gonna crash, and then all my work's gonna be gone. But I hope you guys had a great time. I hope you have a great rest of your night. I hope you have a great tomorrow. And that's it. I can't word. It's too late. But thank you guys so much, and I'll see you tomorrow. All right. Bye for now. It's too late for English.